Greetings, I'm Squared here, and today we are going to talk about transformations and absolute value functions. So, the normal, what we call the parent absolute value function, when nothing funny has happened, is right here. Y equals the absolute value of x. But it doesn't always look like that. In fact, most of the time it doesn't. When you first start out learning it, you just learn about that one. But we're going to talk about the translations that happen. So, you can have a number in front of the absolute value, you can have a number inside the absolute value, added or subtracted, and then one added or subtracted outside the absolute value. You can also have one here, but I didn't put that there because we're not going to learn about that in Algebra 1. We'll save that for Algebra 2. So you can just know that there could be something there. Well, each one of these things does something different to the graph. So you should know by now that an absolute value, a parent function, looks just like that. Slope of 1 on the right side, slope of -1 on the left side, vertex at 0, 0, axis of symmetry at 0. We've done that already. You should know that. Now we're going to see what happens to the vertex, the domain, the range, the axis of symmetry when different things happen to it. So you've got to have this kind of in your brain. So when you have an h and a k here, the vertex is hk. Now the tricky part about that is that says minus h. Our formula says minus h. So when you see an h here, you know it looked like a minus h there. For example, if this was 5, then it said minus 5 here. Well, how would you get a minus 5 here then? Well, that would look like a minus a -5, because a minus a -5 would turn to a plus 5. So notice that's the trickiest part there. The k, that says plus k, this says k. So k is fine. It's just that h that's going to be tricky for you. Okay, notice that our axis of symmetry is x equals h. That means whatever is right here, ignore the minus sign. So whatever's right there, if it's a plus sign, then it's a minus sign. Or you can say that it's the same as the x-coordinate of your vertex. So this is super important. You definitely want to memorize that. So here's all the fun things that can happen. So what does a do? When a is less than 0, let's remember what kind of numbers are less than 0. They're negative numbers. So when you see a negative out front here, you know it's upside down. It has reflected over the x-axis. Super important to remember that little negative. Notice this says the absolute value. So that means ignore the negative, just take the absolute value of a, and if it's bigger than 1, like 2 or 5, we've already been studying that, right? It makes the slope of the different sides of the absolute value. One's negative, one's positive. So if a was 5, then the one side would be slope of 5, the other side of -5. We call that a vertical stretch. It actually gets skinnier. When it's between, the absolute value of a is between 0 and 1. Okay, so up here we gave an example of 5. Let's say this one said 1/2. It compresses it. It kind of pushes it down. So this side would be a -1/2 slope. This side would be a positive 1/2 slope. We've talked about that. And now on to h and k, which we have not done at all. So h and k move things left or right. Notice again, this is the tricky part. H, remember what I said? If it says plus h, it actually moved left h in h units. If it says minus h, it actually moved to the right. Normally we think of right as being positive and left as being negative, but remember our formula said minus h. So it's a little tricky there because in the formula it says minus h, that means h would be positive when that was minus. And then k, when it's positive moves up, when it's negative moves down. So you need to kind of have that all in your notes. You need to use it often. So have that beside you when we are doing our examples here. So let's do some examples. So what we want to do is, I'm going to zoom in a little bit. We want to find the slope of each side, and that's using a. We want to see if it's negative, because if it's negative, it's upside down. We want to find the vertex, and then we want to put it all into this beautiful equation. So we're going to figure out, is it going left, right, up, down? So notice this one. It normally would sit right here, right, the parent function, but this one's up too. I'm going to check out the slope. Looks like the slope is 1 on this side, so I know that a is 1. It's not upside down, so I know that a is positive. What's my vertex? Okay, my vertex is 0, 2. It's shifted up 2. Which one affects that? Which is h or k? You'll look at your little notes. It's k. Oh, and I wrote it like this. Okay, so you might be thinking, what is that? It's the same thing Sometimes they use it like that, but we put k on the other side. So see what I did? I just added k to both sides. So we'll keep it like this. Okay, so our vertex is that. Our axis of symmetry then, right, would be x equals whatever that is, so x equals 0. So let's write our equation. Y equals, a was 1, so I really don't need to put a 1 there. If you want to, you can. I'm just going to say x, and then k is what shifts it up, so I'm going to say, oh, I meant to say, sorry, I meant to say plus 2, not plus k. Let me scribble it out. Put it there. Okay, so our equation is the absolute value of x plus 2, because it moved up 2, and the slope was 1, so a didn't change. Okay, let's try this one. What's our vertex? 1, 2, 3, 4, 1, 2, 3. So our vertex is -4, +3. Let's check out the slope again. Again, that's a slope of a 1 over 1. My slope is 1, so I know a is 1, right? My slope is 1, a is 1. So here I go with my equation. X, now it moved left 4. This is my h. So remember, my formula says minus h, which means it's plus, because it was a minus a negative, and then it moved up 3, so that's my k. It would be plus 3. Alrighty, let's try another one. Okay, so now it's upside down, so that means the slope, this side of the slope is -1. M equals -1, still looks like 1, yep. So that means my a is going to be negative. You don't have to put the 1, but you can. And what happened? It moved up 1. Remember, this is 0, 0, so that you're looking to see where it moved from that. Up 1. It didn't move left or right, so I have my, oh, I meant to not put the 1 there. Anyway, you can put a 1 out there. Let me darken this in so you can tell the difference between my 1 and my absolute value sign. It didn't move left or right at all, so no h. But it did move up 1, so that's k, so that's 1 plus 1. Okay, let's look at this last one. So let's find the slope. Up 2 over 1, my slope is 2. It's not upside down, so I know my a is 2. So there we go. It moved right 4, because my vertex is 4, 3. So it moved right 4. Do you remember what I put there? Remember? Right is -4. And then it moved up 3, and that's a plus 3. So that is how you write equations of absolute values, by finding the slope, finding the vertex, and plugging it into that formula. Oh, forgot. There's a few more. Okay, so here we go. We are going to find the slope. Looks like it's down 3, right 1. It looks like it's -3, so that's y equals -3, absolute value of x. Looks like it's shifted 4, so that's plus 4, and then no k because it wasn't shifted up or down. Vertex is negative, remember, 4, 0. Almost messed that up there. Okay, y equals, its slope is up 2 over 1, so that's 2x. Vertex is 4, -3, so that's -4, -3. Make sure you get that one part in the absolute value. And then this guy goes outside it. Okay, it's getting faster as we get better, huh? Y, well, it's the slope. It looks like it's 1. It's upside down, so that means -1. I'll make a big absolute value sign. And then I have an x. It looks like it's shifted left 2, so that means +2. Looks like it's shifted up 1. So my vertex would have been -2, 1. You can see that there, axis of symmetry, -2. Okay, last one before we start start with the equations and go and describe the transformations. It looks like it's -4, 1. So my equation, it's upside down. Slope is -2 on this side, so I know I'm going to have a -2. Absolute value is x plus 4 plus 1. Okay, so now what we're going to do is I'm going to give you an equation, and you have to tell me what has happened to it. So we're always going by this original parent function. So according to that parent function, what has happened? Well, you can see that there's a 2 out front. Nothing else has happened. So we want to use these words when we're describing it. So remember, if you can go back to that original sheet in your notes, and it says that when it's out here, it's stretched. It's vertically stretched. So we're going to say this is vertically, you can abbreviate if you want, stretched. And then we use a scale factor of 2. That means everything is multiplied by 2. Like the slope used to be 1, but now it's multiplied by 2, so the slope is 2. So that's what happens out there. So we just say scale factor of whatever that little guy is out there. All right, this one. All it is a minus 7 out there. So we can say, oh, it shifted down 7. The down is the negative part. Okay, we are not graphing these, we're just describing the translations. Translation is just that it's moved. Okay, we got a minus 3. That means it went right 3. Remember when it says minus 3, it's actually right 3. And over here, the only thing that's different is there's a little minus sign out there. I don't know if you remember that. I might not have mentioned it, but that means it's reflected. I said upside down before, but it's reflected over the x-axis. That's what happens when it's negative. Okay? Now we've got some combo things going on. So now there's more than one thing going on here. We've got it vertically compressed. And the reason we're saying vertically is because remember I told you we worry about this inside one later? That's horizontally. So we've got to make sure we say vertically. It's vertically compressed. It's shrunken, if that's a word. Compressed. And it's went left 4, because that's what that guy right there tells us. This one went right 1 and down 8. Okay, so you think about that. Think about what's happening there. Hopefully you've said, oh, it's upside down, right? So it's reflected over x-axis. And then what's the 3 tell us? It tells us it's vertically stretched. That 2, that plus 2, tells us that it went left 2. And the minus 11 tells us it went down 11. Okay, last one. Now, don't freak out just because it's decimals. We'd say the same thing. We'd say it's, first of all, is this number between 0 and 1 or bigger than 1? It's between 0 and 1, so that means it was compressed. So we say it's vertically compressed. And then if your teacher tells you to use the scale factor, our scale factor, I'm just going to say SF for scale factor, would be 0.2 or 2/10. Then we went left 1.7 and, I'm sorry, not right, up 5.2. So you need to be able to look at equations, and when you look at them, know what each part does, know what A does, know what H does, what K does, and get really good at just looking at that and having a vision in your head of what that thing looks like. Good luck with that. M squared signing out.